So let's just solve this equation, which is a logarithmic equation. And what I see here is that you have to use some of the properties of the log. I want to just kind of like remind you a couple of the properties that are very useful when you try to solve a logarithmic equation. First of all is the sum. So when you have the sum of two logs of the same basis, like here, log base 3 of A plus log base 3 of B, you are actually multiplying the logs. When you have a difference here, like log base 3 of A minus log base 3 of B, you are dividing this. So think in terms of like exponents. Remember, when you have exponents like A to the power of M times A to the power of N, what you're doing, you're actually adding the exponents. Where with the log, you're going the opposite, because the log function actually is the inverse function of the exponents. So we've noticed here that we have the difference of two logs, therefore we're going to use this property. So based on this property, we can rewrite the whole expression as log base 3 of 2x minus 5 over x to the second plus 4x plus 2 equals 2. Now you always have to look at the conditions of the log. And since you have log functions, you need to set your expression, your log here, this one, 2x minus 5 over x to the second plus 4x plus 4 greater than 0. Because your solutions, you might get different solutions that are actually not in your domain. So by setting your conditions 2x minus 5 greater, actually that should be just greater, because you cannot take the log of 1, you cannot take actually the log of a negative number. So your condition here should be just greater, not even equal to 0. Let me just greater than 0. And here this one should be the same, greater than 0, not greater than or equal to 0. So solving these inequalities, you're going to see that your function or your solutions for this equation only should include values that are greater than, let me just, sorry, I need to put this condition only greater than 5 over 2, or x should be greater than negative 2. So when I look at my solution set, let's say somewhere here is 0, and then I have negative 2, and then my other condition is 5 over 2. Let's say this is 5 over 2. So if I have, for this condition, greater should be from here further. And for this one, when I look at the intersection, it looks to me that I can only have solutions from 5 over 2 going toward infinity. Now, I cannot solve a log equations if I don't have the same logs equals with log something. However, we know from the exponent's properties, we can write an exponent equation as the log or vice versa. So for example, if I have 2 to the power of 3 equals 8, 2 is my base, 3 is my exponent, I can actually write the inverse of this one by saying log base 2 of 8 equals 3. So what I'm doing here is just I'm going to convert the log equation as an exponent because I want to get rid of the log. So my base is 3, my exponent is 2, so I'm going to write 3 to the power of 2 equals 2x minus 5 divided by x to the second plus 4x plus 4. So from here, I'm just going to solve this rational equation. So I'm going to cross multiply 9 times x to the second plus 4x plus 4 equals 2x minus 5. And then I'm going to actually put everything in the standard form because I want to solve a quadratic equation. So what I'm doing, I'm going to move everything on one side. So I'm going to subtract 2x, and then I'm going to add 5. And my results will end up as 9x to the second plus 34x plus 41 equals 0. Now, this is really hard to factor out because you have big numbers. So I always tell my students to actually look at the discriminant. And if I think about The discriminant, I think I pronounced that right, is b to the second minus 4ac divided by 2. So if I look at this equation, a is 9, b is 34, and c is 41. So by replacing into the discriminant formula, I can see if I have real solutions or imaginary solutions. If you recall from Algebra 2, if your discriminant, so if b to the second minus 4ac, 4ac is greater than 0, that means you're going to have two real solutions. They're totally different. I'm going to say the first solution, x1, is not going to be equal with the second solution, but these two solutions will be real, so they belong to all real number. If your discriminant b to the second minus 4ac is equal to 0, you're going to have two solutions that are real, so x1 equals x2. If not, they're going to be complex. So since your discriminant is less than 0, therefore you have no solutions. And hopefully this is going to help, and good luck.